Welcome to Lesson 5-2, Solving Quadratics by Factoring. This is the only video in this lesson. This should be a pretty quick and easy, simple lesson, but it is going to set us up with a strong foundation for when we head into factoring in 5-3. Now, in this lesson, we're going to build upon the ideas that we were working in 5-1. We were graphing from intercept form. We're going to look specifically now at solving quadratics, which means to find the zeros of a quadratic function. Now, in this lesson, we're going to specifically look at solving quadratic equations in factored form. We consider a polynomial to be in factored form if it's written as the product of two or more linear factors. That's the same kind of situation that we were looking at in our last lesson when we were graphing from intercept form. Now, we have a very specific property that is going to help us out with figuring out our solutions when we are solving quadratics by factoring. And that property is called the zero product property. And what that says is if we let a and b be real numbers, then if a times b equals 0, then one of those two factors, a or b, has to be equal to 0. The only way we can get 0 from a multiplication problem is if one of the numbers we're multiplying by is actually 0. So if we're looking back at the last example, or the last lesson, and we were given something in factored form, or intercept form also known as, if we had something like x minus 3 times x plus 2, then what that tells us is when we are solving for these, what we're looking for our zeros. So that is when y is equal to 0. So for this to equal 0, I know that that's a product of two numbers. That means one of these two factors has to be 0. So if the first one was 0, it doesn't matter what x plus 2 was. Since this is 0 times some number, it's still going to give us 0. And the same thing as if we switch those out. If we had x minus 3 times x plus 2, and we said the x plus 2 one was going to be 0, then it doesn't matter what the first term is going to be. It's still going to give us a product of 0. So, what we are going to do now is look at the specifics for how to solve a quadratic equation using factoring. So, we're going to follow a few important steps. The first is going to be that we are going to make sure each equation is in intercept form. In this lesson, all the ones that we're going to give you are going to be in intercept form. In lesson 5-3, when we start in factoring, then we will go ahead and look at how you can change it to intercept form if you are not already in intercept form. The next thing we're going to do is set each factor equal to 0. Remember, we said that if either one of those factors is 0, then we are going to have a product of 0, and we will solve each equation. Now, I do want to point out to the side here, when we're doing this type of problem, you might see several different names that you're asked to find. They all mean the same thing. They're just different words for the same thing. You might be asked when solving a quadratic to find the zeros. You might be asked to find the x-intercepts. You might be asked to find the solutions, or you might be asked to find the roots. All four of these things are exactly the same. They're just four different ways that you'll see this asked. So let's go ahead and jump into an example. In example 1, we're asked to find, or asked to solve for x plus 6 times x minus 3 equals 0. So we know that the sum has to be 0, and we are going to set it equal to 0 if it doesn't specifically do that when we're asked to solve. And so what we need to do now is set each factor equal to 0. So I'm going to take the first factor, x plus 6, and I'm going to set that equal to 0. And I'm going to take the second factor, x minus 3, and I'm going to set that equal to 0. Now what I'm going to do from here is just solve equations. And these should be pretty basic 1- to 2-step equations. This should not be that difficult. If you need a refresher on solving 1- and 2-step equations, refer back to Unit 1. But let's go ahead and solve these. So to get x by itself in our first example, in x plus 6 equals 0, we would have to subtract 6 from both sides, and we would get x equals negative 6. We would do the same thing with our other one. We would take the minus 3, to get rid of that, we would have to add 3 to both sides. So we would get x equals 3. And that is our two possible solutions. We'll talk about later in later lessons what our different outcomes are. But what this is doing, and we have a graphic here to illustrate, we got the answers of x equals -6 and x equals 3. If you'll notice on the graph, what this matches up to are those x-intercept values that we were using to help us plot our graphs earlier. -6 is right here. We have the x-intercept of -6, 0, and the 3 is over here. So what we're really doing in this, and this is where we want you guys to draw that connection, is that when we are solving, what we're actually looking for are these y-intercepts that tell us where the graph is going to cross the axis. Now this is going to have several practical applications. We're going to get into some projectile problems in future lessons where you're going to be launching something and you want to know how long until it hits the ground. And also at the end of the year, we're going to do a project that's going to revolve around quadratics. We're going to build some catapults, and we're going to predict where they'll land based on the model for your catapult that you come up with. It'll be modeled by a quadratic. Let's go ahead and keep doing some examples for now, though. We'll get to that fun stuff later in the year. Now, sometimes you might see something written a little bit differently. It's technically an intercept form, but it's just a little bit different. And that's going to be what we're looking at in example 2. In example 2, we're given 2x minus 3 squared. Now, before we can work this problem, we need to think about what it means for something to be squared. Remember, when we square something, it means that we are multiplying it by itself. So a way to rewrite this would be to write out the 2x minus 3 and then times it by itself, 2x minus 3, and set it equal to 0. Now remember, when we are solving these, we want to set each factor equal to 0. So we are going to set our first factor equal to 0, which would be 2x minus 3. We're going to set that equal to 0. And then we're going to set our second factor equal to 0. So 2x minus 3 is going to be equal to 0 again. Because if either one of these is 0, that means our total sum is going to be 0. So what I want to do now is solve this simple equation. I'm going to add 3 to both sides. I'm going to get 2x equals 3. And then I'm going to have to divide both sides by 2. And I'm going to get x is equal to 3 halves. Now, before I even begin the other problem, I'm going to take a look. If you notice, these are the exact same thing since they were squared. So we could go ahead and solve this, but what we're going to find is that we're going to get the exact same answer, x equals 3 halves. So notice in this case we only get one solution. That would be the situation where your vertex is actually going to be your x-intercept. So that would be something that only touches the graph one time. It might be something that looks like this, if it will let me draw it, where it comes down, touches once at the vertex, and then turns around and goes back the other way. So it is possible that sometimes we may only get one answer. And we'll take a look at those further in detail in the future. For now, though, let's move on to example 3. So in example 3, we are given another situation. Now notice this time that they are very similar, except one is going to be x plus 6 equals 0, and one is going to be x minus 6 equals 0. So we're going to have very similar answers on this. The first thing we'll need to do on the first equation is subtract 6 from both sides, and we get x equals -6. And then on the second equation, instead of subtracting 6 this time, we want to add 6. So these kind of problems really illustrate the importance of paying attention to your signs and make sure you're using the correct inverse operation. So in this case, I'm going to get two answers of -6 and +6. They're two completely different answers, but you will see that they came from something that looked very similar. This is actually a special case called the difference of squares that we'll look at in a little bit more detail in the next lesson. But for right now, we just want to focus on saying each part equal to 6. Or each part equal to 0. Sorry, I misspoke there. Alright, one last example. This is just written a little bit differently. You'll notice that the first set does not have parentheses because it doesn't have a plus or a minus number after it. We're going to still follow the exact same process. This time we're going to set the 3x equals to 0 because that's all that we have for that first factor. And then we're going to go ahead and do it with the second one. I'll start with the second one on this one because it's one that you're more familiar with seeing. So we would subtract 6 from both sides, and we would get x equals -6. Now this is one that did throw some people off when we were solving equations. A lot of people wanted to think that just because one side of the equation was equal to 0, it was going to be no solution. This actually is not the case. Remember, anytime we have two numbers next to each other, that means we're multiplying. To undo multiplying, we have to divide everything by that number. So we're going to divide both sides by 3. The 3's will cancel, and I get x equals 0 divided by 3, which is 0. So I would have my two answers of x equals 0 and x equals -6. Alright, that wraps up video 5-2. This should be a pretty easy lesson. It shouldn't be too difficult for you guys. If you do run into the problems though, please let us know. We're glad to help you out with any questions that you may have. For now, go ahead and give the U-Tries an attempt. Make sure you check your answers on the website. Get started on that practice and then prepare yourself for the mastery check. Alright, see you guys in the next lesson.